In this video, we are now going to take a look at variation models. Please know there are two different ways you are going to know our story problems are variation. One way, it will tell you in the problem, and it'll actually tell you your equation right in the problem. And we're going to start with those to practice them so you can see what it looks like. The second type of situation is it's going to be a regular story problem like you're used to. You're going to pull out coordinate points and then you're going to find your equation. Very similar to what we did when we wrote the variation equations. We're just going to have 2 points generally. Those are going to be the two different situations. So we're going to start with the first case where I give you an example in words and you're going to be able to write your equation straightforward from this. So it says the area varies directly with the square of the height. Now, keep in mind, we will be defining our variables when we're doing large story problems, but in this case, we'll just use variables that make sense. So it says the area varies. The first one is the y value. Okay, area is the y value. That's the one that's going to sit by itself. And then as soon as I see the word varies, I know it's going to be a k value, that constant. So area, let's say we're going to use A for area, equals... So this varies, which means it's k. Now, the word after will tell us whether it's a direct variation or inverse variation. It might also say, instead of varies, it might say it's proportional. Same type of situation. So it varies directly, so my x value is going to be over here. With the square, that's going to be my n value of the height. That's my x. So h squared. So a equals kh squared. So that's the first equation that you're going to be practicing. Now, I'd have to give you some kind of information. You plug in for your h and a value, you solve for your k, and then you have the equation that you can use for your stories. So here's the next one. The length of your arm varies inversely with the cube of the length of your foot. See if you can write this one right away at the beginning. So the length of your arm varies, which means this is that y value. And whatever variable you want to use for this, the length of your arm, so maybe I'll use an A for arm. Story problems, you will definitely be defining those. So A equals, it varies inversely, varies K. Since it's inverse, it's going to be over. And then it says it's inversely with the cube of your foot. So your foot cubed. So A equals K over F cubed. Now it can give you an X and a Y value, in this case an A and an F value. You can solve backwards and find your K, and then you can put in some other values and keep moving from there. Okay, last one. The number of desks varies directly with the number of students. What I want you to realize with this problem, it doesn't give you an N value. Like up here it said the cube. Further up, it said the square. It's not giving you what n is. Because it does not physically tell you what n is 1. N is 1. That's important for you to understand. So I can just write my equation. Desks varies. D equals K directly with the number of students, S. Because my n is 1. You don't have to put the 1 there. But that's going to be the other situation that you have to be careful about, is sometimes that exponent is just 1. So those are all just straightforward. Here's your information, write your equation out of it. This is the second type. Take a minute, write this down, take a look at what the problem is. To begin with, I'm going to have to define my variables that I'm going to be using. I'm going to have to I'm going to set this up in table form just because that's how we learned how to write our equation, was based off of our table form. So to begin with, I have to define what my variables are. So it says the pressure required to force water through the garden hose depends on the number of gallons per minute you want to flow. So right there it tells you what your x and your y values are. So in this case, one of my variables might be g. Just for consistency's sake, we'll use g. And g is just the number of gallons per minute. You want the water to flow. And then the other variable maybe we use is P, because we're talking about pressure. P is the pressure. Make sure you use complete sentences, more or less. to force water through a garden hose. In PSI. Now it's important to make sure that you know which one's your X and which one's your Y. Now again, as soon as we get to that depends on, that variation piece, that's going to tell us what's what. So here's my word depends. So the pressure depends on the number of gallons, which means your pressure is your Y value, your gallons is your X value. So this is going to be G, comma, P. Okay, so that's the important part that you have. Now I have to pull all my information out of here as well based on my coordinate values. So I'm going to pull my coordinate points out of my problem. So I have up here that there's 3 gallons per minute has a pressure of 10 psi. So 3 gallons per minute has a pressure of 10, and then 6 gallons per minute has a pressure of 40. So now what I'm going to do is I'm going to write my table just so that you're used to how we actually write the equation, because right here it tells us this is a variation equation. So when I set up my table, so I have my G values and my P values, so 3 and 10 and 6 and 40. By no means do you have to set up a table, but it's definitely very helpful. Now because this is variation, I know it's multiply, multiply. So I multiply by 2 on the left-hand side, which means I multiply by 4 on the right-hand side, just because of what it takes, the second one divided by the first. So I know this is going to be, this one's increasing, this one's increasing. This is going to be a direct variation. So P equals KG to the n. I know those variables get kind of funny. If you want to use your X's and Y values, that's absolutely fine as well. So I know that 2 to the n has to equal 4. Now you've had this practice already writing variation equations. This is a straightforward one, n is 2. So far my equation is P equals KG squared. So now I have to find my K value, so I'm going to plug in a coordinate point. I'll just use the first one, doesn't matter which one you plug in. So 10 equals K times 3 squared. So 3 squared is 9. Divide both sides by 9. K is 10 ninths. Therefore, my equation is pressure equals 10 ninths, my gallons per minute squared. And then I could answer other questions based off of this information. If I needed my gallons per minute to be a certain number, what would the pressure have to be? And if the pressure had to be this in order to get the water through, then what does my gallons need to be? Gallons per minute, that is. So this is the process you are going to use for story problems. My opinion, the table makes this a little bit easier to set up because you can see the multiply factor a little bit better, but by no means do you have to.